everyone, it's me, Miss B, and today's video we are looking at the cumulative practice problems for Unit 6, Lesson 5 of Illustrative Math Algebra 1. So, this unit is all about quadratics. So, you can see the shape in this first question here. That is a parabola. So let's look at this graph and kind of read through and see, and we'll do this homework assignment together. So complete the following while showing all of your work. A rocket is launched in the air, and its height in feet is modeled by the function h. So you'll notice they said that it was the height, meaning that's how far it is off the ground. Whenever you talk about your own height, you're talking about how far the top of your head is from the ground. So this is not necessarily how far it's fallen, but this is how far from the ground. Okay, so here is a graph representing h, which is the function. Select all true statements about the situation. So we're going to look at each of these and see if it lines up with our graph. The first one here says that a rocket is launched from a height less than 20 feet above the ground. So we're looking at less than 20 feet of a launch height. And that actually is what we're going to look for in our initial value, or where it touches the y-axis. So 20 feet would be right here. I would definitely say this touches at less than 20 feet. So this first option works. But now this is select all true statements, so I don't need to put a check mark. Select all true statements. We're going to look at all of our potential options and see which ones work and which ones don't necessarily. The rocket is launched from about 20 feet above the ground. Well, it's launched from less than that, so I'm going to say it's not about. It looks like it's more like maybe 10. The rocket reaches its maximum height after about 3 seconds. So seconds is down here on the x-axis, or the horizontal axis here, and the maximum height is going to be right there. It's literally just the tallest that it goes, and this is around 3 seconds. It's a little bit more, but that looks to me like after about 3 seconds. So I'm going to say that C is also correct. The rocket reaches its maximum height after about 160 seconds. Well, 160 is not the time in seconds. That's actually about the height of it. Plus, we already said it's after like 3 seconds, not 160. So not this one, but the very next one says the maximum height of the rocket is about 160 feet. And that one is true. So A, C, and E, and that is, E comes from this one right here. That's the maximum height. C comes from the x coordinate, which is the time it reaches that. Okay, so that's it for our first question. Let's keep going and look at number 2. A baseball is traveling d meters t seconds after being dropped from the top of a building. I might like add a comma in here, but that's just me. The distance traveled can be modeled by the equation. So they're giving me an equation. I'm going to highlight this here. D is equal to 5t squared. So we want to complete the table and then plot the data on the coordinate plane. Okay, well, let's actually see. I think I can actually split screen here, and we're going to use... Oh, it doesn't quite show. It might if I do this, though. I'm going to change how I'm presenting this. There you go. So you can see I also have my calculator over here, my Desmos Scientific Calculator. I am going to use this while we calculate this one here on the left. So we know that our function is d is equal to 5t squared. So I can plug in and say 5 times something squared, and my first number here is 0, and then we want to square it. So that's how I'd enter it on the calculator. And you can see it says our actual answer here is 0. Well, that is because it is actually 0. 0 squared is 0, and 5 times 0 is still going to be 0. So this one here would be 0. But that number is going to go up. Now, it might be easiest to do this with 1 and with 2, and you can probably actually do those ones in your head. So we can do 1 squared and get 1, and then when we multiply that by 5, we should get 5. And that's what I see for my answer over here. So this one is 5. If we did 2 squared, we should get 4, and then we would have to multiply that with the 5, and we should get 20. So let's plug that in. And we get 20. But these numbers, the 0.5 and the 1.5, get a little tricky, so we're definitely going to use the calculators for those. 0.5, not 20, 0.5. And you can see I get 1.25 for my answer here, so we're going to put 1.25. And when we put 1.5, 1.5, we get 11.25. Since you'll have access to a calculator, especially for your tests, it's always okay to use a calculator here. And this app on the right-hand side that I'm using is the Desmos Scientific Calculator. You can access it by going to desmos.com/scientific. They also have a 4-function calculator, but this one does more of like the squared things, and I like it a little better. Plus, you can see that you can change your answer to display as fractions on the right-hand side. If you press this little button here, it'll switch it in between fractions and decimals. So I think that's pretty neat. Okay, so let's clear that. We're going to go back to full screen here, and we will look at our just our page here. So let's actually graph these, because it says compare the table, or sorry, complete the table. We did that, but it says and plot the data. So we're going to plot the data. At 0, we have 0, so make sure to put a point at 0, 0. At 0.5, we have 1.25, so that's going to be, I don't know, kind of small, maybe down right there-ish. At 1, it's actually 5, so right here. At 1.5, it goes up to 11.25, so that's going to be a little bit above 10. And then at 2, it goes up to 20. So right there. Those look pretty accurate to me, and you can even connect them with a little bit of a curved graph if you want. Mine's a little off. I wonder if it'll allow me to, sure, make a nice pretty one like that. There we go. Okay, so now question B says, is the baseball traveling at a constant speed? And explain how you know. If our baseball was traveling at a constant speed, that would mean it's going the same number of meters every second. And that would mean it's a linear function. So one of the ways I can explain this is by looking at my graph. This is not a straight line. A straight line would be like this. And that's not what we have. So we can say, no, it is not traveling at a constant speed because it is not linear on the graph. We can even also say it is speeding up, because it is speeding up. Because of gravity, it's going to fall faster and faster and faster. So that's actually it for question 2. They didn't give us a ton of room to write, but we made it work. Question 3 is looking at these things down here. So I'll read the whole instructions, but we won't need most of the space horizontally. So it says determine whether 5n squared or 3 to the power of n will have the greater value when, and then it's giving us values here. N is equal to 1, n is equal to 3, and n is equal to 5. And we are going to place a greater than, less than, or equal to inside each box. So that's our instructions. I'm going to zoom in a little bit here so we can maybe see my handwriting a little better. And we're going to evaluate each of these. Now you can use a calculator for this point if you want. It's always a good idea. So I'm going to pull mine up just for me, but you'll be able to use your own. So here, we're going to plug in 5 times 1 squared. And if you plug that in your calculator, 5 times 1 squared, you should get, well, 5 times 1, which is just 5. And if you plugged in 3 to the power of n, where n is 1, this is really 3 to the power of 1. And that would give you 3. So now we decide which is bigger, 5 or 3. Well, I know that 5 is bigger, so in that box, I'm going to put greater than, and it's going to face towards the 5. We're going to do the same process now with n being 3 and then n being 5. So if we did 5 and then times 3 squared is 9, and times 5 would create 45. Then we're going to have 3 to the power of 3, which is 3 times 3 times 3, and this will give us, no, not 81. This is going to give us 27. Sorry, 81 is if we had one more. So this would be 27, because 3 times 3 is 9, and then 9 times 3 is 27. So it looks like my number on the left is still bigger, so I'm going to put a greater than symbol here. Now, on the last row, we're going to do this with 5. So we're really looking at 5 times 5 squared. 5 squared is 25, and then times 5 again is going to make 125. So we would put 125 right here, and then 3 to the power of n, we're going to use 3 then to the power of 5, and this, I would definitely use a calculator for this one, because it's not one you might know off the top of your head, but this is 243. So finally, the one on the right is actually larger, so we can put a less than symbol and say 125 is less than 243. And that's really it for that question. It's just those. So that's the front page. We're going to move on to the back. And this is only one page, so nicely enough, we'll just have, one page front and back. A nice short kind of homework assignment. So looking at now question 4. We have a rock that is dropped from a bridge over a river. So dropping it from a bridge over a river, I like to annotate and I kind of like to point out what we're measuring, and this is the distance in feet that it has fallen, not the height. So we want to know how far has it fallen. Now, if you're super, super observant here, you might notice that it doesn't super make sense for us to have 1 second and it's fallen 0 feet. But you can ignore that part. We're gonna, for my peace of mind, I'm gonna change this. So instead of being 1, 2, 3, and 4, for each of these, you can imagine this is 0, 1, 2, and 3. So 0, 1, 2, and 3, and same goes for the tables down here. if we're starting at 180 feet, that should be at 0 seconds. So after we fix that up, we want to look for how many feet it has fallen. So it only makes sense. We have two options when we look at our tables here. So let me backtrack here. I have either a table where I have numbers that are starting small and then growing bigger, or I have tables with numbers that are starting big and then they're getting smaller. Since I want to be measuring that it's the distance it's fallen, I should be starting with a smaller number that's then growing towards a bigger number, because the longer it's in the air, the longer it's going to fall, or the farther it's going to fall. So right away, that means I can say it's not going to be table C and it's not going to be table D, because both of those start at a larger number and then they get smaller. So I can take those two out of my running or my equation, or I can just ignore them essentially. So we now have table A and table B. Table A and table B. I know that if an object is falling, I want this to be a quadratic function. So I want to check and find which one here is quadratic. And we can do that by checking the differences. So let's check and find the difference here. And difference is just a mathematical way of saying subtracting between these two numbers. So the difference here is 48. It's going up by 48. We kind of use the difference when we look at slope, so you can think of it that way. If I find the difference between 48 and 96, that also turns out to be 48. And if we look at the difference between 96 and 144, that's also 48. So table A, this one is actually linear. And since I know that it's linear, I can just stop right here and say, well, it has to be table B. But we're going to look at table B, and we're going to talk about, we're going to look at the difference, and then we're going to look at something called the second difference. So for each of these here, let's look at, I guess, what we would call the first difference. Just like we did on the previous one, the difference here, that's 16. Now the difference here is, I believe this is 48. I'm going to check myself on that because I don't always trust myself with subtraction. Let's see, 64 minus 16. Yeah, 48. Okay. Then we're going to do 144 minus 64. And that one gives us 80. So this is our difference. But we want to take this one step further and say, okay, well, now what's the difference between these red numbers? So this, and what I have in red, is called the difference. So I'm going to label that here. And then this part I'm writing in blue, we're going to call the second difference. Okay, running out of room on like the edge of my paper here, so I'm trying not to write off the edge. All right, so 16 and 48. So let's do 48 minus 16. And for this one, you'll get 32. So now we're going to do 80 minus 48. And this one you'll also get 32. So whenever the second difference, or the difference of the differences, is the same, that is your hint that this is a quadratic relationship and that it has something to do with x squared. So our answer is going to be table B, and we're going to say I'm going to say here, the reason or what I use to show here is that the second difference is, we'll say constant. That just means that it stays the same. Because the first difference is kind of like our slope, and so that's why table A, when we found 48 for that difference each time, that's what tells us it's linear. But it's the second difference that tells us that something is quadratic. So that's question 4. We're going to look at one last question here, and then we'll be done. So question 5 says a small ball is dropped from a tall building. Which equation could represent the ball's height in feet relative to the ground? So we want representing the ball's height h in feet. So that means how far from the ground. And this is as a function of time t in seconds. So we're looking for something that would describe how far this ball is from the ground. We have a couple options here. They all start with 100 minus. So 100 minus, that's good. Maybe we're starting at 100 feet, and then we're subtracting how far this ball fell. So that part doesn't really tell me what this one should look like. That means I can move on and just kind of look at this part, what's left over. And in this case, that's my parts involving the 16 and the t. And only one of these is quadratic. It's actually going to be B. So let's make this one a different color maybe, because this is the only one that has something to the power of 2. So this is going to be my choice for the answer. This is, now it doesn't ask me to explain why, but I'm going to say this is the only quadratic, and I'll say maybe this is like x squared function. Because when you have quadratic, I like to think of that as just meaning x squared. It's the only one with, in this case, t squared. And that's it. Just those 5 questions. They're a little complicated, some of them, especially that one with the second difference, although there's other ways to do it. But that's it. So hopefully this video was a little bit helpful. This has been the cumulative practice problems for Unit 6, Lesson 5 of Illustrative Math, Algebra 1.